In every civilization, people have asked, what is the world made of? From stones and smoke to metal and blood. Everything we touch is chemistry. Welcome to Uncover Time. Here we follow how the curiosity of ancient minds led to one of the most powerful sciences in the world. Before chemistry, there was fire, the first tool humans used to transform nature. Ancient Egypt used fire to smelt copper and turn sand into glass, but their work was guided more by magic than measurement. The Greeks offered early theories. Thales thought everything came from water, while Empedocles proposed 4 elements: earth, air, fire, and water. Democritus imagined atoms, tiny invisible particles in constant motion, a radical idea that would vanish for centuries. In China, Taoist philosophers explored transformation through balance and opposites, a system that guided alchemical practices. Indian thinkers describe life as made of 5 elements: earth, water, fire, air, and ether, linking them to health and the universe. Meanwhile, Hebrew texts like the Sefer Yetzirah explored mystical views of matter, showing how religion and early science often intertwined. When Islam spread across the Near East, it brought learning with it, and with that learning came the rise of alchemy. Muslim scientists translated Greek texts and added their own experiments, changing magic into early science. Alchemists believed they could turn cheap metals into gold and find the elixir of life, a magical potion to cure all disease. Though these dreams were never fulfilled, their methods led to progress: distilling liquids, isolating acids, and creating lab equipment. Jabir ibn Hayyan, a Muslim scholar in the 8th century, is sometimes called the father of chemistry. He wrote about acids like sulfuric and nitric acid and developed tools like the alembic, a kind of early distillation flask. In medieval Europe, alchemy mixed Christian mysticism with Greek and Islamic thought, blending prayer with experiment. Alchemists wrote in symbols, hoping to protect their secrets and maybe discover the philosopher's stone, a mythical source of transformation. Paracelsus, a 16th century Swiss physician, argued that alchemy should focus not on gold, but on medicine, to heal, not to transmute. By the 1600s, natural philosophers began to favor careful experiments over secret symbols. Chemistry was emerging as its own science. Robert Boyle helped define it. In 1661, he published The Skeptical Chemist, challenging the old 4-element theory and calling for observation and proof. Boyle used an air pump to study gases and found that pressure and volume were linked. This became Boyle's law. In France, Antoine Lavoisier carried chemistry forward by naming elements and proving that combustion involved oxygen, not the release of fire. He designed experiments to measure chemical reactions precisely, showing that mass is conserved. What goes in must come out. Lavoisier helped build the first modern list of chemical elements, defining them as basic substances that could not be broken down further. With his wife Marine, he also translated, illustrated, and published his findings, creating tools to teach and spread chemical knowledge. His life was cut short during the French Revolution, but his legacy became the foundation of modern chemistry. In the 1800s, John Dalton revived atomic theory, suggesting that matter is made of indivisible atoms, each with a specific weight. Dmitri Mendeleev organized these atoms into the periodic table, a breakthrough that arranged elements by weight and predicted missing ones. Across Europe, chemists like Avogadro, Berzelius, and Cannizzaro clarified atomic weights, bonding, and symbols, giving chemistry a global language. Experiments revealed that atoms could combine into molecules with fixed ratios, like water always forming from 2 hydrogen and 1 oxygen atom. Electrochemistry advanced when Humphrey, Davy, and Michael Faraday used electricity to split substances and isolate new elements. By the late 1800s, organic chemistry emerged, revealing the complex molecules inside living things and opening the door to synthetic materials. The rise of the chemical industry brought dyes, fertilizers, plastics, and medicine, changing economies, health, and daily life. In Germany, Fritz Haber and Karl Bosch turned nitrogen from the air into ammonia, making fertilizers that fed the world and explosives that fueled wars. In England, Rosalind Franklin used X-rays to photograph DNA, helping Crick and Watson understand life's molecular code. In the 20th century, atomic theory was tested by splitting atoms and discovering subatomic particles. Today, chemistry has advanced into realms once thought impossible. Scientists design molecules to treat cancer, purify water, and store clean energy. From nanotechnology to quantum chemistry, from CRISPR to carbon capture, the power of chemistry continues to shape our world and our future. It began with questions and flame. It grew with balance, structure, and the search for truth hidden inside matter. And still, it grows, revealing not just what the world is made of, but what we might become. Thank you for watching UncoverTime, where the past of science becomes a map to the future. Like, share, and subscribe for more.